Long-standing questions about how the brain produces conscious experiences have baffled scientists and philosophers alike. Some skeptics question whether science's objective tools will ever be able to comprehend such a subjective phenomenon. However, scientists have started to pinpoint the adjustments in brain activity that come along with awareness, and they also have some intriguing hypotheses about how consciousness evolved. Hello and welcome to another episode of Curious Media. Discover your inner detective. From puzzles to unexplained events, we'll bring you the mysteries that need solving every day. So make sure you subscribe to our channel and hit that bell icon to never miss an update. Today in this video, we are going to explore the mystery behind the human consciousness. So strap your seatbelts, as this is going to be an exciting journey. One of the great mysteries of life is how the brain generates conscious awareness from the electrical activity of billions of individual nerve cells. We can all agree that we are conscious. That is, we have thoughts, perceptions, and feelings, but we are unable to demonstrate this to others. The mysterious essence that enables us to have those thoughts, perceptions, and feelings is only available to us. David Chalmers, a philosopher, referred to this impossibility to objective, outside inspection as the hard problem of consciousness in the 1990s. He suggested that the neural correlates of it, or the locations and patterns of brain activity that change when people have conscious experiences, would be an easier problem for scientists to solve. In addition to pure curiosity, researchers are likely driven to learn more of the neural underpinnings of consciousness in order to better understand and treat disorders of consciousness like persistent vegetative states and some psychiatric conditions. 3 dimensions of consciousness. They can measure several different aspects of consciousness, but there are 3 most crucial aspects. Wakefulness or physiological arousal comes in first. The second one is awareness, which is the capacity to have conscious mental experiences, such as thoughts, feelings, and perceptions. And finally, number 3 is sensory organization, or the process by which various perceptions and more abstract ideas come to be intertwined to produce a seamless conscious experience. Our overall state of consciousness is the result of the interaction of these 3 dimensions. For instance, we are in a high-energy state when we are wide awake. Vivid dreams are most likely to happen during REM sleep, when awareness and physiological arousal return. However, most of these sensory experiences are isolated from outside stimuli and from the ideas that, while we are awake, ground us in reality. Similar to this, normal levels of arousal are present during altered states of consciousness, including those brought on by psychedelic drugs or low oxygen levels. These include auditory, olfactory, and visual hallucinations, as well as synesthesia, which is the interplay of normally distinct senses, such as sounds that evoke visual perceptions. Even lower levels of wakefulness and awareness than those experienced during non-REM sleep are possible in people who are comatose or under anesthesia. Patients experience daily cycles of wakefulness and sleep, but without displaying any signs of awareness, in a strange hybrid state of consciousness known as unresponsive wakefulness syndrome, also known as a vegetative state. They remain alert for extended periods of time, but they don't react behaviorally to outside stimuli. The brain's connections to consciousness. Important hints about the neural correlates of consciousness have been provided by patients in various states of consciousness. Through measurements of functional connectivity, researchers can identify patterns of activity by revealing correlations between the timing of neural events in various brain regions. This reveals the neural networks in the brain that, for instance, control working memory, attention, and daydreaming. Researchers find that activity in the thalamus, located deep inside the brain, changes during wakefulness in tandem with activity in the default mode network when they combine data from fMRI and EEG. The default mode network is a group of areas within the cortex, the outermost layer of the brain, that are deeply involved in mind wandering and self-awareness, whereas the thalamus functions as a sensory relay station. The terrain of brain activity. However, despite progress in our knowledge of the neural correlates of consciousness, medical professionals still struggle to identify patients who are unable to respond to commands or questions. They are unable to distinguish between a patient who is totally unconscious, conscious but unresponsive to outside stimuli, or conscious and aware of their surroundings. A completely novel strategy, recently reported in Nature Communications, may offer a way to evaluate the wakefulness, awareness, and sensory organization of such a patient. The new method measures gradients of activity throughout the brain as opposed to recording activity in specific brain regions or networks of regions. This is comparable to mapping not only the locations of roads, towns, and villages, but also the steepness of the terrain and how that steepness may change over time. This novel approach to study brain activity takes into account the multiple functions and connections that each network and region have, as well as how functional geometry shapes temporal dynamics. Consciousness is complex, and studying it is like solving a scrambled Rubik's Cube, as Dr. Zaruk Lom puts it. You might find it difficult to understand how something is set up if you only look at one surface. Work on the puzzle while considering all its dimensions. So there's still a lot to learn about human consciousness, and we are unable to reach a proper conclusion. What are you thinking in your conscious mind right now? Let us know in the comments. If you found today's video to be interesting, then do show us some support by clicking those like and share buttons. Thanks for watching.